Okay, so based on this example here, it says that your external frequency, which is your clock frequency, is 8 megahertz. Okay, so external equal to 8 megahertz. And then you are required to write a program that generates a square wave of 1 to 5 hertz. Okay, so you need to generate a square wave. Okay, so the frequency of this square wave is 1 to 5 hertz. And then this square wave you're going to generate at port B pin number 3. Okay, so this square wave we produce from port B pin number 3. Use timer 0. Okay, so by using a timer 0, normal mode, and prescale to 5/6. Okay, so you're going to do the program. Okay, so first thing first, what you're going to do is, okay, now we are going to find out what are the delay that we are going to generate based on this information of our square wave here. Okay, since it seems that the square wave frequency is 1 to 5 hertz, then you can find out what are the period of this square wave. Okay, so you need to figure out what are the period of this square wave. Okay, t square wave equal to 1 over f, in which this f here is your frequency of the square wave. Okay, so 1 divided by 1 to 5 hertz, and then you will get, berapa kamu dapat? 8 microsecond. Okay, so this is the period of your square wave, which is t equal to 8 milliseconds. Okay, once you get the t 1 milliseconds, then you need to find out what are the delay that you're going to generate. Since this square wave, okay, you see here, the duty cycle of the square wave is 50% for the high, logic high, and another 50% for the logic low. So you need to divide this t by 2. So you know that you are going to generate a delay of 4 milliseconds. Okay, because the delay is half cycle of this square wave. Okay, so by using a timer 0 normal mode with a prescale to 5/6, then you're going to do the program. Okay, so first, what you're going to do is, based on this step here, you're going to load the TCNT. Since you didn't know the TCNT value, so what you're going to do is you need to find out what are your TCNT based on the equation. Okay, you have 3 equations, which is T sama dengan 1 over F. Okay, since this one here, we are going to use a prescale to 5/6. Okay, so you're going to find out what are your new F. Okay, so cari dulu your F new equal to, okay, 8 megahertz divided by 256. Then you will get 31.25 kilohertz. Okay, so this is your F new. Okay, once you get the F new, then after that you need to find out what are your period. Okay, your new period based on this prescaler 256. Okay, so those t equal to 1 over 31.25 kilohertz, and you will get your t is berapa ya? Kamu akan dapat your t equal to 0.032 millisecond, which is equivalent to 32 microseconds. Okay, so next. Okay, this is the equation 1. Okay, next, apply equation 2, which is delay equal to period times with count. Okay, so you have the delay. Okay, so this is your delay. And then you have the period. Then you're going to find out what are your count. So count sama dengan delay. What is your delay that you're going to generate? 4 millisecond divided by T. So the T is 0.0032 milliseconds. Then you get what are the total count that you're going to have? 1 to 5 times. Okay, this is your total count. Okay, then after that, you can find out your TCNT. So TCNT sama dengan FF minus count plus 1, which is FF. You can tukar dia, change it to a decimal, which is 255 minus 125 tambah 1, then you will get, okay, berapa ni? Tolong, do you have a calculator? Okay, 1, 3, 1. Okay, so 1, 3, 1. Change back to hexadecimal, you will get 8, 3. So this is the TCNT value that you're going to load to your TCNT. Okay, so next you're going to do this program lah. So I assume that all of you already know how to initialize your port and how to do the square wave. So now I'm going to focus on this part only. Okay, on the timer programming only. So on top of this one here, so I assume that you already know how to initialize the input-output port, how to program your main program, as well as what are inside of your while loop based on the question given. Okay, so now I'm just focusing on this timer programming. Okay, so now we're going to do our timer programming. Okay, let's lah. Your punya timer programming name is void. Okay, so this is your timer function, timer 0 form microsecond. Okay, you can put void. Okay, and then open curly bracket and close curly bracket down here. Okay, so now if you see here, okay, you're going to use the normal mode and Prescaler. Okay, so first step here, what you're going to do is, okay, you're going to load your TCNT. Okay, so load your TCNT. Since this is a timer 0, so TCNT that you're going to use is TCNT 0 lah, equal to 0x8 3. So this is your TCNT value based on the calculation that you calculated earlier. Okay, so this is step number 1. Yes, then step number 2, set your TCCR. Okay, you're going to set your TCCR. So TCCR 0. Why 0? Because this is timer 0. So TCCR, you are going to use the TCCR 0. So what value that you're going to put to your TCCR 0? Okay, based on this here, okay, you need to remind back lah. Okay, recall back the TCCR 0, which bit that you need to initialize. Okay, so bit 6 and bit 3, this one is for mode settings. Okay, either normal mode or CTC mode. If you're going to use a normal mode, so you need to put 0, 0 here. If you're going to use the CTC mode, and then you need to put 0, 1. Okay, and then this one here. Okay, the last 3 bit. Okay, so this is your prescale. Okay, so what are the value that you're going to put to your prescale for 256 prescaler? Berapa value? Okay. If you put 000, so this one stop timer. 001, this is 8. And then 010, what is 010? I already. Is it 32 or 16? 010. Can you check back? What is the value for the 010? And then you have 011. Okay, sorry. It is no prescale. Yes, correct. 001 is no prescale. Okay. 010, this is 8. 011. Okay, 64. And then 100,256 and 101 is 1024. Okay, then you have 110 and 111. Okay, so this is used for count as a counter. Okay, so now since we are going to use the 256 punya prescaler, okay, so this is the value lah of the 256 that you're going to put. Okay, so the value that you need to put to your TCCR 0 is actually 00000 followed by 100. Okay, so TCCR 0 equal to 0B0000 and 0100. Okay, so this is timer 0, normal mode with prescale 256. Okay, again, this one in the binary representation, you can change it to hexadecimal by, okay, write TCCR0 equal to OX04. Okay, so this is step number 2. And then step number 3, okay, you're going to monitor, since this is a normal mode, timer 0, so we're going to monitor our TOV0 flags. Okay, so to monitor, so you just write down Y, okay, and then TIFR N kan dengan TOV0, and then is it equal to 0? Okay, if yes, then it will keep looping. If the TOV0 inside the TIFR equal to 1, then this one will become false. So it will exit from this while loop. So this is the third step. Okay, the step number 4, okay, you're going to stop the timer. How to stop the timer? By writing TCCR0 sama dengan 0. Okay, and then step number 5, clear TOV0. So how to clear TOV0? So TIF, okay, by writing TIFR equal to OX01 ataupun or TIFR equal to, okay, shift 1 to TOV. Okay, then close curly bracket. Okay, so this is your timer 0 programming to generate 4 millisecond delay. Okay, any question? Up until here, any question? Okay, this one we use a prescaler. Okay, previously we doesn't use the prescale. Okay, the difference is for the prescaler, so you need to find out your new F. Okay, based on the prescaler. When you get the new F, then you get your T lah. When you get your T, then you apply to the equation. Okay, the rest is same. Okay, a part of the setting of your TCCR. Okay, if no question, then we are going to move to CTC mode. Okay, so we are going to learn the second method to generate a delay by using a compare mesh. Okay, CTC mode means that clear timer 0 on compare mesh. Okay, so in this TCC mode, okay, you're going to compare your TC and T with another register called OCR register. Okay, so this is your TC and T. If the TC and T equal to the OCR register, and if equal, then the OCF flag will set. If not, then the TCNT will keep increasing. Okay, so as in the normal mode, okay, in the CTC mode, the timer is incremented with a clock. Okay, sama lah juga. Okay, the CTC mode and normal mode, this TCNT value will increase with your clock source. Okay, but it count up until the content of your TCNT equal to your OCR. Okay, then once the TCNT value equal to your OCR value, then what happen here, the timer will be cleared and OCF0 flag will be set. Okay, so this OCF0 flag is located inside of your TIFR register. So this is what happened lah. So this CTC actually you can run it periodically. Okay, compared to overflow only run one time unless you call another, you call it again. So you can do it repeatedly. Okay, so let's look at this example here. So in the following program, you are creating a square wave of 50% duty cycle with equal portion of high and low on a port B pin number 5. Okay, timer 0 is used to generate a timer delay. You're going to analyze your program. So this is the main program, okay, in which you're going to initialize your port B so that your port B, okay, pin number. So this one here, please change to DDRP, okay, shift 1 to location 5 because we are going to use the port B5, not port B3. This one also you need to change lah the value, okay, because this one here you're going to toggle PB3, not PB5. Okay, so this is the program, okay, for the CTC mode timer programming. Okay, you see here TCNT 0 equal to 0 means that you load the TCNT with 0. Okay, recall back for the CTC mode, okay, by using the water bottle. So what you're going to do is you need to make sure that your water bottle is empty at the start of the timer. Okay, so TCNT should be 0. Okay, so that's why the first thing that you're going to do is, okay, you initialize your TCNT with 0, and then after that you need to set your level, your water level, okay, which is this is by setting it at your OCR register. So this is your OCR value that you're going to set, and then after that, okay, you do the timer setting and monitor the OCF flags, stop the timer and clear the OCF flags. Okay, so this is the step that you're going to do, okay, in order to write for CTC mode. Okay, so CTC mode. Yes. Step number 1, clear your TCNT. Step number 2, okay, load your OCR register, the OCR value. Step number 3, set your TCCR. Okay, so in this case here, since this is a CTC mode, make sure that, okay, bit 3 and bit 1, bit 6 and bit 3, you put 0, 1. So this is bit 6 and this is your bit 3. Okay, and then followed by the prescale lah. Either you using a prescale or not using any prescale. Okay, and then step number 4, okay, you're going to monitor your OCF flags. Okay, so monitor OCF flags. Okay, if OCF flag equal to 0, so what happen? The TCNT will keep increase. Okay, you count the TCNT. Okay, if the OCF flag equal to 1, so what you're going to do is exit from loop. Okay, step number 5, stop timer. Okay, how to stop timer? Sama jugalah dengan normal mode. Just put your TCCR and with 0 value. Okay, this is how you're going to stop your timer. And step number 6, clear your OCF flag. And then it will, okay, and then you will, this one will keep repeating. Okay, so this is the step that you're going to do in order to program your delay by using a CTC mode. Okay, so okay, this is the what we call here the summary of this program here. Okay, you can read it by your own. So what happened here, and then okay, now you're going to see. Okay, assume that the external U is 8 megahertz. Okay, so you're going to write a program to generate a delay of 25.6 milliseconds. Use timer 0 CTC mode with a prescale of 1024. Okay, so now I'm just focusing on the delay programming. Okay, so how to do that? Macam mana nak buat? Okay, so before that, in this CTC mode, okay, there are equation that you're going to use. Okay, a part of this equation here, 1 equal to t equal to 1 over f, and then delay equal to t times wave count. Then you have another equation that you need to use is, okay, so this is equation number 3 for your CTC, which is OCR equal to TCNT plus count minus 1. Okay, so this is the equation that you're going to use in order if you use the CTC mode. Okay, usually this TCNT will set it with 0. Okay, we will load our TCNT with 0 for CTC mode. Okay, so this is the equation. Okay, so let's look at this, what we call here examples here. Okay, it says that assume that X is 8 megahertz, write a program to generate a 25.6 milliseconds. Okay, use a CTC mode with a prescale of 1024. Okay, so how to do this? How to write the program? Okay, given that Esther sama dengan 8 MHz, timer 0, CTC prescale 1024, and delay is 25.6 milliseconds. So what are you going to do? Okay, first thing first, because this one here involve of prescaler, so you need to find out what is your F new, which is F new sama dengan 8 MHz. Okay, divided with 1024. So you will get apa sini dapat? Can somebody please press the calculator. Dapat berapa? Okay, ada tak? 7.8125 kilohertz, is it? Okay, 7,812.5 hertz. Okay, which is equivalent to 7.8125 kilohertz. And then you find out what is your T. T sama dengan 1 over F new, which is equivalent to 0.128 millisecond, which is equivalent to 128 microsecond. So this is your T. Okay, so this by using the equation number 1 lah. And then by using equation number 2, what is the equation number 2? It says that delay equal to T times with count. Okay, T times with count. Okay, so delay, you know that the delay is 25.6 milliseconds. T is 0.128 milliseconds, and then you need, now you're going to find out what is your count. So count equal to, what is your count? You get 200 times. Okay, ataupun 200 clocks. Okay, and then step number 3, okay, by using this equation here, which is OCR, because this is you're going to use the CTC mode. Okay, so OCR sama dengan TC and T plus with count minus with 1. Okay, so this one is 0, kosong tambah dengan count is 200 minus with 1, you get 199, which is equivalent to, okay, 199 in hexadecimal. What is the value in hexadecimal? 199. Okay, C7. Okay, now we are going to write the program. Okay, let's lah. Void timer0, okay, CTC void, and then open curly bracket and close curly bracket down here. Okay, what is the first step? Okay, to write program for the CTC mode. Okay, so you're going to clear your TC and T. Okay, so TC and T0, you put 0. Okay, this is your first step. First step is clear your TC and T. Okay, clear TC and T. And then the second step here is, okay, load your OCR value. Okay, so OCR 0, because timer 0 equal to 199. Ataupun you can use OCR 0 equal to OXC7. Okay, step number 3, your TCCR setting. TCCR 0 setting. Okay, so based on this one here, mana tadi kita punya tulis? Okay, this one. Okay, since this is what we call here, we are going to use the CTC mode. So the value that you're going to put here at bit 0, 6 and 3 is 0 and 1. And then you're going to use a prescale of 1024, correct? Okay, so 1024 is 1001. So 101. Okay, so the value that you're going to put here is 0B001101. Okay, so 0B0000101. So this is in binary lah. Okay. Or you can write down in hexadecimal, which is equivalent to berapa ni? OX 84 is 12, 12 tambah 1, 13, A, B, C, D. Kosong, D. Okay, so you know that the setting here is, CTC mode prescale 1, 0, 2, 4 based on this value. Okay, lepas tu, next, what are we going to do? Okay, we are going to monitor our what flags we are going to monitor, because this is CTC mode. So you're going to monitor your OCF flag. So Y TIFR and with OCF0. Okay, because we're going to monitor the OCF flags, which is OCF0. Is it equal to 0? Okay, if yes, what happens if yes? If yes, it will keep monitoring. If not, if the OCF0 flag inside in this TIFR is 1, so what happens? It will exit this while loop. So once it exit while loop, what you're going to do is, this is a step number 5, which is you're going to stop your TCCR0. Okay, once you stop your TCCR, okay, stop your timer. Then after that, you're going to clear your OCF flag. So TIFR sama dengan 0x02. Why 02? Because this is your TIFR. Okay, so this is your TOV0, and this is your OCF0. So that's why the value that you're going to put here is 0000010, which is equivalent to 0x02. Ataupun you can write down TIFR, okay, equal to OCF0. Okay, and then close curly bracket. So this is how you're going to write to write the program for by using the CTC mode. Ada soalan? Okay, we finished the timer 0. Okay, you already learned about the overflow method ataupun normal mode, and then you already learned about the CTC mode. Okay, how to write a program using a CTC mode. Any question up until here? Okay, kalau tak ada soalan, if no question, then we move to Timer2 program. Okay, how to do Timer2 programming. CJ2. What you mean? What are you say? What you're trying to say? Yet in Java, CJ2. Where is a CJ2? Okay, so we move to Timer2 programming. Okay, so Timer2 is similar to Timer0, which is a 8-bit size in ATmega32. Therefore, it works same as well as the Timer0 programming. So all the programming are similar. Okay, there are only two differences between Timer0 and Timer2, which is the Timer2 can be used as a real-time counter. Okay, and in Timer2, more prescaler option can be found. Okay, so Timer2 cannot, this one is cannot be used as a real-time counter. Why it cannot be used as a real-time counter? Because in Timer2, you doesn't have the what we call here. Okay, does have the setting to count a certain event. Okay, because this one here to count a certain event or now is replaced with the more prescale option. Okay, as you can see here. Okay, the setting is the same. Okay, for bit 6 and bit 3. Okay, will determine your mode. Either you're going to use a normal mode or CTC mode. Okay, while the last 3 bit here, this is only for your prescale option. Okay, if you put 000, sama lah, no clock source, which is you're going to stop your timer. 001, no prescaling. 010, okay, you use a 8 prescale. 011, now you have the 32 prescale. Previously, from 8, we have the 64. Now you have the 32 and 100, 64 prescaler. And then you have 101, it is another prescaler here. Okay, additional prescaler, which is 128. 110 is for 256 and 111 for 1024. Okay, so this is the prescaler. Okay, you have 2 additional prescalers here. Okay, which is 32 and 128. Dekat sini. Okay, the rest is same. Okay, so we finish our Timer2 programming. The way you're going to write that programming in normal mode and CTC mode are similar to Timer0. Okay, I hope that there is no question here. Okay, so now we are going to learn about Timer1 programming. Okay, so this is the most powerful timer lah. Why? Because it has 16-bit. Okay, if you have the 16-bit, it means that you can create a larger delay. Because previously, okay, our timer is only 8-bit. Okay, so the maximum count, okay, the maximum count that the maximum number that you can count is 255. Okay, which is for the 60-bit, the maximum count that you can counting is 65 kilo. 65,000. Okay, ada lagi lah nombor belakang ni. Okay, 65,000 berapa? I don't remember the. Okay, 65,535. Okay, 65,535, which is equivalent to your FF. Okay, so this is a 255, which is equivalent to FF. Okay, this is FF, sorry. Okay, so this timer one is 60-bit timer and has lot of capabilities. Okay, since timer one is a 60-bit timer, so you can split it into 2 bytes lah. Okay, because it is 16-bit. Okay, you can split it to 2 bytes, which is first is a low byte. The second one we call it as a higher byte. Okay, so the low byte we call it as a TCNT1L. Okay, so this one is belong to the timer 1 low byte. For the timer 1 high byte, okay, it's labeled as a TCNT1H. All right, so this is your timer 1. Okay, the TCNT of your timer 1. Okay, so it is a 16-bit. Okay, since it's 16-bit, then you can divide it to low byte and high byte. So this is your low byte and this is your high byte. Timer 1 has 2 control register. Okay, they are the dual control register. Okay, previously only have 1 control register. Okay, to do a setting. But for timer 1, you have 2 control register called a TCCR1A and TCCR1B. Okay, similar to timer 0 and timer 2, the TOV flag will go high whenever the overflow occurs, and timer 1 has a prescaler option of no prescaler with a 8 prescaler, 64, 256, and 1024. So you have 4 prescaler to choose from. Okay, only timer 2 you have 6 prescaler. Okay, which is 8, 16, sorry, 8, 6, 32, 64, 128, 256, and 1024. Okay, there are two OCR register in timer 1. Either you're going to use the OCR1A ataupun OCR1B. So of course lah, since this OCR1A and OCR1B is what we call here is 16-bit, so you can divide it into low byte and high byte. Okay, so whenever the TCNT1 equal to OCR1A, so OCF1A will goes high. Okay, if you're going to use the OCR1B to compare with TCNT, then when these two have same value, then the OCF1B will goes high. Okay, so this is the summaries, okay, of timer 1. Okay, in which this is your TCNT1. Okay, you have a TCNT high and 1 high and TCNT1 low. Okay, and then you have two OCR, which is OCR1B high and OCR1B and OCR1A. If you're going to compare your TCNT1 with OCR1A, then the OCF1A flag will go high whenever these two values is equal. If you're going to compare with OCR1B, then you're going to monitor the OCF1B flag. Okay, and then this is the setting. Okay, for the setting, you have a TCCR1A and TCCR1B to do the setting for timer 1. Okay, so inside of the TIFR register, so this is the location that you're going to focus for timer 1, okay, which is TOV1. This is for overflow timer 1, and then OCF1A and OCF1B, this is for CTC mode. Okay, depending on which OCR that you're going to compare, is it OCR1A ataupun OCR1B. Okay, next we are going to look at our TCCR1A and TCCR1B. This is where you're going to put your timer settings. Okay, so here, okay, we look at our TCCR1B dahulu, and then after that we follow with our TCCR1A. Okay, for the TCCR1B, the bit that you need to familiar is, okay, this last 3 bit here. Okay, bit 0, bit 1, and bit 2. So this is your prescaler. Okay, this is your prescaler option. If you put 000 means that you're going to stop the timer. 001, no prescaling. 010, prescale 8. 011, 64. And then 256 is for 100. 101 is 1024. Okay, if you put the 110 and 111 means that you're going to, okay, you're going to read the external clock source on your T0 pin. Okay, so this one here actually to count an event, to make your timer as a counter. Okay, then another bit that you're going to familiar is for TCCR1B is this bit here, WGM13 and WGM12. For the TCCR1A, you need to focus on these 2 bits here, WGM11 and WGM10. Okay, so this is the setting lah. Okay, for the WGM13, 12, 11, and 10, in which, okay, we are going to focus on this part only for normal mode. So this is the value that you're going to put, which is 000, 0, and 0. Okay, and then we have the CTC. Okay, so this is your CTC. This is the value that you're going to put. Okay, 01. Okay, 01, 00 means that you're going to use a CTC mode, but using the OCR1B. Okay, to compare with the OCR1B. And then another CTC mode, which is this is the value here, 1100. Okay, so this one here, you're going to use another CTC mode, but to compare with OCR1B. Okay, if you put the 1100 dekat sini, So means that this is a CTC, but okay, this one you are going to compare with OCR1A. If you put 1, so this is a CTC, but this one you're going to compare with OCR1 bit. Okay, by right, okay, by default, the TCCR value, you can safe assume that this one, the value you need to put 0. Okay, because even though you make it as a normal mode, the value of the WGM11 and WGM10 always kosong. Okay, if you select the CTC mode, also the value is 0, 0. Okay, another CTC mode for when you compare with OCR1B, the value 0, 0 as well. So you can assume that the TCCR1A always 0. Okay, so on this, okay, you can conclude that only the setting that you need to make is only on the TCCR1B. So according to this, what we call here, setting lah. Okay, so I just okay. Okay, so this is your timer 1. Okay, for TCCR1A, okay, you're going to put 0, while TCCR1B, okay, the setting here depending on your value here. Okay, so this is the Prescaler. And this is your setting. Okay, if you put 0, 0 kat sini means that this is a normal mode. And then when you put 0, 1, this is a CTC, but you're going to compare with OCR1A. If you put 1, 1, so this is another CTC, but you're going to compare with OCR1B. Okay. Okay, again, your timer 1, okay, you can divide it into 2 modes, which is a normal mode as well as CTC mode. Okay, so normal mode, okay, the value that you're going to put is 0, 0, 0, 0. Okay, the cut WGM30 to WGM10. So in normal mode, the timer count up until it's reached FFFF. So this is the maximum lah inside of your TCNT. And it will roll over from FFF to 0, 0, 0, 0 means that the TO, whenever it's roll over from FF to 0, 0, which is the overflow occurs, then the TOB1 flag will be set. So this is your TCNT value. And sorry, okay, so this is your TCNT will keep increasing until FF. When it roll over from FF to 0, then the TOB will equal to 1. Then you're going to reset back lah. So that your TOB1 sama dengan kosong, and then you keep monitoring. Okay, for the CTC mode, okay, so this is the setting that you're going to put, okay, which is either 0100 ataupun 1100. But okay, for 0100, you can compare with OCR1A. If 1100, you can compare it with OCR1B. So in CTC mode, the timer count up until the content of your TCNT equal to your OCR, which is when this one, the both value are equal, okay, the timer will be cleared when the next clock occur, and then OCF1A flag will be set. Okay, so this is the summary of the CTC mode. Okay, I think we stop here. Okay, the example we are going to do it in next week. Okay, in the next class. Okay, any question up until here? Ada soalan tak?